Assumptions are statements taken to be likely true, but without supporting evidence. Analysts use assumptions to fill in gaps or address conflicting information to support their analytic conclusions. Assumptions might be based on past behavior or comparable but unrelated situations, or common sense reasoning about cause and effect. There is no evidence in the problem description that the truck left with a canister. However, in the context of the other actions of the considered scenario, one may assume to be certain that this event happened. In general, one has to assess the probability that an assumption could be true under the current situation and also to justify this probability. When should we make an assumption? Consider this inference. A video segment on the security camera showing a person loading a canister into a U-Haul panel truck. From this, we infer that it is likely that the stolen canister was loaded into the truck. A relevance, which is less than almost certain, is an indication that there are missing sub-hypotheses in the argument. Try to imagine an additional sub-hypothesis of this hypothesis, which would make the argument's relevance certain. The security camera shows that a canister was loaded into the truck. If we make the assumption that the loaded canister is a missing cesium-137 canister, then we can create an argument with relevance certain. Notice that the probability that the stolen canister was loaded into the truck is still likely. The advantage, however, is that now we have made explicit what before was a hidden assumption. This increases the persuasiveness of our argumentation. Notice also that we have inserted the event a canister was loaded into the truck above the evidence E7 about this event. This is because we may have other evidence about this event either favoring or disfavoring it. We now have all the elements for a system such as Cogent to infer the probability of the top hypothesis. Based on the evidence, we have determined the probabilities of the simplest hypothesis. We have also estimated the probabilities of the two assumptions. The probability of the hypothesis the canister was stolen from locker, very likely, is obtained as a minimum between the relevance of its argument and the probabilities of its sub-hypothesis. Similarly, the probability of the hypothesis the stolen canister was loaded into the truck, likely, is obtained as a minimum between the relevance of its argument and the probability of the sub-hypothesis. The probability of the scenario that was hypothesized, likely, is obtained as a minimum between the relevance of its argument and the probability of the sub-hypothesis. Further up, the probability of the top hypothesis, the cesium-137 canister was stolen, likely, is obtained as a minimum between the relevance of its argument and the probability of the scenario. We have assessed the probability of the stolen hypothesis. Next, we will assess the probability of the second main hypothesis. The cesium-137 canister is used in a project at the XYZ company without being checked out from the XYZ warehouse.